All right, it looks like it is 2:30 and my mic is on, so it must be time to start. Hi everyone, I am Rachel Reese, and this talk is Mobile Development with F#. So it was going to be a full talk on Xamarin Forms, and I decided to throw in one demo that is not fully Xamarin Forms, so I changed the title. And I did notify the folks about 3 weeks ago, but apparently it was a bit too late. So it is not fully a Xamarin Forms talk, and I thought I'd mention that right up front. So there will be a lot of F# though, and I always like to start with story time, because everyone loves story time. So my absolute most favorite testimonial, and I got these off of fsharp.org website, is from Simon Cousins. And Simon works for some power company in the UK, I don't know which one. And he had a very, very standard business application written fully in C#, endless maintenance, endless new features, 2-week sprints, just your standard enterprise application. He decided that, he discovered F# and thought, I think this is really going to solve some of my problems. And was able to, he and maybe 2 or 3 other devs on his team were able to go off into a corner, rewrite the entire application in F# and delivered it over to the business. I think they took 3 months to rewrite the entire thing. After that time, they delivered it over to the business folks and didn't hear anything back. No, he went to them, maybe a month later, was like, so is it terrible? Have you used it at all? Is it, what's happening here? I need feedback of some sort. They came back to them and were like, no, it's perfect. It's fine. It has all the features we wanted. They all work exactly correctly. We haven't found any bugs. We've been using it, the past couple weeks, and it just works, so we haven't come back to you with any other requests. He first wrote this, I think, 3 months after that original conversation where, they needed no additional work done. It's now been 3 years, and he has done 0 additional work to it. It's just out there, it's running, it's basically working perfectly. It's almost like an Erlang app, if any of you folks have used Erlang. Almost. So that's Simon, and that's, there almost isn't a better testimonial. Jan did a very, very similar thing. When he was with the GameSys company, and they do Facebook games. I know there's a poker game. I don't know the other ones they do. But he had a very similar situation. He learned F#, and this time he went off into a corner by himself and rewrote the game's entire backend in F#. He was able to do this, let's see, he replaced an entire team of Java developers. I think there were 9 of them. I thought it was originally like 3 or 4 when I first heard the story. So he replaced 9 of them, and he was able to go from, choosing to make the switch into production in 6 weeks. And, just by merely switching to F#. The company that I work for, Jet.com, did a similar thing. They decided on F# actually, to begin with, for one section. Now, there were rumors several years ago that F# is good for math and science things because it's functional. And well, that is true. It is also good for many other things. But the company I work for is an e-commerce website, and we have a pricing engine. And so the CTO thought, well, that's a perfect reason to use F# in this pricing engine. And as the first developers were hired on, we had a few very key people who are very interested in F#, and a couple C# developers as well. And there started to be a lot of conversations about, should we keep this in F#? Should we move this portion over to C#? Where should those lines be drawn between F# and C#? And we ended up choosing F#. Our backend is basically 95, 98% F#. It's very, very, very rare that I see anything that isn't F#. But they made that decision based on a lot of cross-cutting concerns of logging and validation and all of those things. A lot of the libraries they were looking at to handle those sorts of things, and for example, in Web API, it's very common to use an attribute, to inject a function call beforehand, and using injection is often a way to handle these sort of things. We needed a way to handle this sort of thing for services that weren't based on HTTP, and there weren't really any libraries out there that handled this nicely, and there wasn't an easy way to do this at all in C#. With F#, it's just an extra function call that you insert into a list. It became very, very easy to switch over and have much of our code handling, using F# for things like that. So like I said, we're an e-commerce company. And we're very heavy into microservices. I do a fair amount of microservices talks as well. We're the #4 marketplace worldwide. I throw this up just to say that, when I say that we're using F#, we're not some little startup. We have a lot of users. We have some very, very heavy load. We also use a lot of different technologies. We're very, very heavy users of Azure. You may have seen on the previous slide that we are trying to compete with Amazon as an e-commerce website. So we are not very heavy users of AWS. Well, the top blue section is a lot of the technologies that we use from Azure. We have DNS, we have their queues, Active Directory, lots of different things. The green on the side is our data science. F# section is all in orange. So we use a lot of F# libraries, Packet, FSblog, Fake, Chessy. Excuse me. We have Node and Angular on our front end, and then the blue at the bottom is sort of everything else. Xamarin we have highlighted in orange. One, because, yay, Xamarin. Two, because we are heavy users, we use a lot of Xamarin Studio to begin with, and we're starting to prototype some of our apps using Xamarin.Forms internally, but with F#. So we decided oh, that didn't work out right. I switched my slides over to a second computer so that I could have both of them. The iOS and Xamarin iOS and Xamarin Android is a bug I didn't quite catch and is supposed to be on this side. So the reasons to choose, Xamarin.Forms versus going native. The Xamarin.Forms, we're using it mostly because we're prototyping some of the internal apps. And that's the big reason that we went with Xamarin.Forms to sort of work with all of these things. But anything, and this is very similar to the documentation, but this is what we have seen. Anything where there's very heavy custom UIs that you're going to need, you'll want to actually use the Xamarin iOS and the Xamarin Android. So the big exciting thing with Xamarin.Forms is you can, of course, now use, as Miguel calls them, a pickle, which still just, it's a pickle. OK. So PCLs, the shared libraries, which I know many of us folks were using before, the files will compile into your respective solutions. And that is nice. You will need to use the if-else compiler directives. That can get kind of annoying if you have to. So having the PCLs is really quite lovely. And a very quick demo of just the Xamarin.Forms part of one of my apps. And over here, and I, of course, have to log in. There we go. Oh, yay. OK. So I have a type provider demo that I'm going to show you fully later. So let's run this now. So what this does is it connects out to a couple different data sources using F# type providers, one of them being the Foursquare API. Basically gets a list of all of the countries in the world and their capital cities, and then updates with using Foursquare to grab the most highly rated venue in each of the capital cities. So the Xamarin.Forms part of this is, Xamarin.Forms surprisingly simple. So we have our simple main module here, which can be separated out or can be here. In our iOS app delegate, we need to do a forms init. We need to call the type provider demo app, and that is basically it. In the same thing with our main activity over on the Android side, do the same thing. We have a Xamarin.Forms init, and then we load the type provider demo app. It's complicated, you guys. But if you have seen Xamarin.Forms before, this is what that F# will look like. So it should look fairly familiar. We're still overriding a function here. The type provider demo app is, really, again, very complicated here. We have a type app. It tells us where our main page is, this venue list page. And this venue list page I am not going to go into now because this is where I need to teach you guys all of the F# that I'm going to cover on this. So we are using a bit of XAML, though. Thank you, Charles. So back, yay, OK. So back over here, I am going to cover some of these features in F# that we will need to actually know. So F# has what's called a discriminated union. You can think of it sort of in two ways. Yay, OK. The first way, if we don't have this type transport with car, bus, and bicycle, if we don't consider this of make and model and of route and just handle the car, bus, and bicycle, it's very much like an enum. It works almost exactly the same way. It's just a list that you can refer to. You have named ideas. If we have this extra make and model and route information, it's very similar to a simple object hierarchy in C#. Contains basically all the same information. If I can actually get out here. For a car, there's a make and a model that inherits from transport. We have the same bit over here. We have a car that inherits from transport. We have a make and a model and a make and a model and a make and a make and a model and a model. There's just a lot of extra information there. There's no need to have, this public abstract class, the car here, would be in its own separate file. So we have 4 files here, car, bus, bicycle, and the original transport. Whereas over here, we have 4 total lines of code. So F# is obviously much more compact. The C# still doesn't actually have structural equality. It isn't properly immutable. There is a private set, but it's not read-only. It is at least idiomatic, but it still isn't, there's a lot more work to be done to bring it up to what the F# has in just those 4 lines of code. This is also very easy to, so yes, it has the same information as F# as the C#. It's also trivial to pattern match on, and I know C#7 is getting pattern matching. So I assume that many of you are starting to be more familiar with what that actually is. It's a lot like a switch statement. It's a lot more powerful. It would tend to, in the F#, it would actually look like this. Let's get their bios, the name of this function, passes in one of these transport types. Then we just match this transport with, if it's a car with a certain make and model, then do something. If it's a bus, do something else, bicycle. It works very similarly, as I've said, to a switch statement. The fun thing is if you add an additional, here I've added on this train item, the next time you compile, you'll be given warnings every single place you try to pattern match, and you aren't considering the train case. It's this instant check. The compiler just sort of holds your hand and says, hey, I think you meant to add all of these additional features on, or this additional bit of code, and I'm going to make sure you know about that. It is just a warning. You can ignore it at your own risk. But it does, this is one of the many little features of F# that I really like. It's sort of, the compiler kind of looks out for you. F# does tend to be a lot less complex as well. So this is TickSpec, which I believe does BDD testing for projects. So you take one of these little circles and you follow the arrow around, and this bit of code depends on this bit of code, depends on this bit of code. Just a simple dependency diagram. It's fairly easy to look at and figure out what's going on and how the code flows and what's actually happening. This is SpecFlow, also a BDD testing library built in C#. And you can see that it's sort of a mess of a mess. My guess is all of these classes probably up here are something that could in F# be replaced by a discriminated union. There are definitely some circular dependencies in here with this spaghetti mess of code. And one thing, actually, there was a Birds of a Feather yesterday discussing F#. And one of the things we talked about was F# has a specific file order. In Visual Studio, in Xamarin Studio, when you load up the files, they're not necessarily in alphabetical order. They're in the order that the compiler needs to process them. They do this so that you don't have any, for many reasons. But one of the wonderful side effects is that you can't get circular dependencies. So you can't have something that looks like this. There's also there are often comments on whether or not functional programming in general, F# specifically, is performant. Now, this guy, John Harrop, who is honestly one of the smartest people I have ever met, or even heard of, he's really wonderful. He rewrote an existing C++ solution, with 10,000 trades a minute, latencies as low as 50 milliseconds, a million lines of code, 40 devs, 15 years. It was this monster trading app. And he was able to redo it 3 months, 6,000 lines of F#. And it was faster, more performant, much more easy for everyone to handle. And it's, whenever I hear folks saying that functional programming can't be performant, I think of John Harrop being able to write an application that was more performant than C++ actually was. There's, that works out. Another, actually one of my favorite John Harrop quotes is that, this was all done in 6,000 lines of F#. What happens at 10,000 lines? Is the code self-aware? It ends up being very dense, and because of all of the short bits of code. So another thing, the compiler tends to look out for you. And this, I had started to say this a bit earlier with pattern matching. But this is Tomas Petracek. Several years ago, at one of the Microsoft MVP summits, Tomas attended a talk by, I have it, Lucian Wischik and Stephen Taub on when C# first came out with Async. And it was a talk that went over, here are some of the features of Async. Here's how not to use it. If you think that, if you're writing this bit of code and you're expecting this, then you're probably not going to get it, and just be warned. I forget what it was exactly called, but Tomas wrote a post about it, calling asynchronous gotchas in C#, and went on to show off the equivalent F# code. And in general, what Tomas found, he was trying to make exact comparisons, and the original point of the post was to say, hey, F# has these wonderful features, and it's so much, it's more difficult to make these mistakes. But what he found was that it was almost impossible to make the same mistakes. In most of those cases, you couldn't actually write the same code. You couldn't, the compiler and the language itself prevented you from making those same mistakes. And that's sort of the big why F# is again, it's all of those little things where the compiler sort of looks after you and makes it easier for you to do the right thing. So speaking of async, one of my most favorite demos is basically making an app be fairly responsive using F# async. So here's some very basic F# not asynchronous. Let declares both a function and a value. We're newing up a web client, we're downloading some data, and then we're writing the output stream. Three very basic lines of code. This is what that looks like when it's asynchronous. We have the async container around it. We're still newing up a web client. This time we have, we have a let bang here, which starts the computation immediately, whereas the let without the exclamation point saves creates an async object for use later. But we're doing, here we have the let bang, and we're just doing an async download string and printing out the result right away. So the main differences are obviously the async, the let bang, and this async download string. Very, very, very easy to convert to and from asynchronous code. Asynchronous code is very important in using F# mailbox processors, so mailbox processors are based on the actor model in computation. It's a model of concurrent computation based around actors. Actors are these little tiny independent entities which basically contain a queue, and they can process messages. Now, the actor model uses these, and there's 4 sort of rules of this. the actors can be created dynamically. They each have, excuse me, they each have an address contained in the messages that they send, and the only interaction between the actors themselves is through message passing. And the fourth one is there isn't a restriction on message order arrival. So I often like to think of subways as an implementation of the actor model. And actually, I am blanking on his name. I usually one of the main folks who came up with the actor model. One of his famous quotes is that one actor is no actor. They need to come in systems. This is the original idea behind Erlang. They were created to be used on phone infrastructure. So if you think of a phone, if you have just one phone, you can't call anyone. In this day and age, you can play an app on it. That's great. But you can't communicate with your phone. It's like having a chat server that you're the only one logged into. There's no point in that. And sure, you might be able to talk to yourself. I mean, you can send messages. But you need to have a system of actors. You need to be able to communicate these things out and around. So if you think about a subway system, and this is actually the Tokyo one, but any one of these stations could be considered an actor. A train, as a message, comes in, and it gets processed. Some of the people maybe get off and board and switch trains to a different train. Some people get off, it's their final stop. They go up and wander around the neighborhood. Some people stay on that train and continue on to the next stop. There's only so many different ways of processing, and something happens. There is a process each time a train pulls into a station. So the basic syntax for actors in F#. So the other thing is, it's called the actor model. Many people refer to them as agents. In F#, the actual code name, or the type is MailboxProcessor. So you'll hear all three sort of being thrown around. They're basically, within reason, the same thing. So here we have a list expression. This bracket here creates a list. And I'm creating 100,000 actors. Now, actors are not threads. I can spin up 100,000 of them on my machine and have it barely even blink. It's not a big deal. In this case, so here we have a mailbox processor calling start. We have an inbox to contain the message, hold the messages, receive and process them, and it contains this queue in an async loop. So here I have a while true loop. It doesn't have to be functional. You don't have to have it be recursive. It can just be while true. I call it let bang. I sit and wait for a message to be received, and if it's one of the 10,000 agents, then I just print that I got a message. And at the bottom, for all of these agents, I'm just posting a message, ping. What that actually looks like is this. Excuse me, agent 0 got message ping. So it's a very simple, but the point is, there's this async loop contained within here. So my StockTicker demo. Good. Here. Ooh. Okay, well, that's back. This should be popping over to my code. Aw. Go to this one, down. Aw. Okay. Thanks. So close that, open up StockTicker. So this is my not Xamarin.Forms demo, but is one of my favorite. The use of the mailbox processors, and let me open this up. The use of mailbox processors just really makes this a lot of fun to work with. So we have a very simple chart. I'm using tchart because they have an evaluation version that works, and it was free. But the only two controls on here, I have that set up, the chart set up in a simple UI view, and my control down here. So I hit start, and what this is doing is just, you can see the actors are at the bottom are printing out. I'm sampling code or stock numbers from Apple, Microsoft, and Google. Looks like Microsoft is tanking. That's no good. Apple's starting to take off, but it's, let's stop this. So let's start here. So the actual agents, I keep an agent state whether or not it should be stopped or started. I'm just using a simple random formula within, here's my mailbox processor. Here I am doing a recursive loop. Up here, my message type is a reply channel. Basically, the mailbox processor keeps the state within it, has a, is basically making up new numbers at random for what the new stock price could be, and then responding back out to the UI with what those new numbers should be. So this bit of code here, I had to add an async sleep for 1 millisecond. Otherwise, the mailbox processors were going too fast for the UI to actually keep up. So it used to be 2, so there must have been some improvements since the last time I ran this demo. But the UI just completely freezes and doesn't do anything until I hit stop. So my reply channel is this inbox receive. I'm doing a simple quick calculation. I find a sign, whether it's positive or negative, grab a small value, and then add the value to the previous value and respond back out to the UI with what that new value for the stock price is. So obviously, this part of the code is where you would actually go out and maybe check the real stock prices. And then I'm creating 3 separate instances of this, stock agent 3, 4, and 5 for Apple, Microsoft, and Google. I'm not going to go too heavy into, not at all, into my view controller because this isn't Xamarin.Forms. But this is, for the F#, it is done all on the back end. I have start, stop slider here, creating a new segmented control, inserting the start and stop sections. I have my handle segmented changed here. In the view did load, I'm creating the new UI chart. I'm creating the T chart. I had to convert everything to CG-Rex when I updated. But this, and then adding everything to the actual view. So I used to have to do all of this in the back end. But the main point was to show off how the agents interact with everything, which is here. So the stock price agent coming into this, I'm matching the agent state. Basically, if the agent state is stopped, if I've hit stop on my segmented control, then just do nothing. Don't continue on. Don't actually do anything. If it started, then I post. This is how you post to an agent and get that reply. So I'm just posting a message and trying to get back. Stock async, when this comes up, is an asynchronous float. So I'm receiving this message back, which is that new price. And then here, we use a start with continuations to handle that. So if there's an exception, then since this is just a demo, I didn't fill in the exception or the cancellation, but you should do that. So I print this down here, which previously you guys were able to see all of these. So we had almost 1,000. So the Google one had 992 instances, and the last price for Google was 14. The last price for Apple was 7. The last price for Microsoft was -7, or 18, -7. Yeah, whoops. Stock line is each of the lines on the chart. So we just add that reply version number, and then redraw that line with everything. And that's how that chart remains so responsive. So yay, OK, well, that worked coming back. So now, my other favorite feature to use in mobile apps with F# is type providers. Type providers are honestly one of my favorite F# features ever. They are the feature that got me involved and interested in F# to begin with. So what a type provider actually is just a mechanism to provide types to the compiler. But it's a way of interacting with any data source anywhere out on the internet and bringing that into your code and interacting with that. So why do we need these? It's because of our current data consumption methods. If you think of them, our current data consumption methods are a little messy. And we first have to set up the connection. We have to obtain all of the data that we're looking at. We have to create all of this infrastructure around that. If you use something like Entity Framework, it means generating 1 billion classes. And then once we're done with all that, then we can finally look at consuming the data. And not that that's so complicated. It's something that many of us have done several times. But there's a lot of steps there. There's a lot of unnecessary work. And that's something that, in F#, it's about one or 2 lines of code, depending. And that's really it. Once you've written those 2 lines of code, then you can start immediately playing and interacting with your data. It's a lot more fun. It's a lot more interactive. It's a lot easier, again, to prototype something quickly and make sure that what you have is the right bit of code. So it's a lot more natural with a REPL. In F#, there's, at the bottom of both Xamarin Studio and Visual Studio, there's a REPL, read, eval, print loop. Basically a little shell that you can type F# into and evaluate it and see what the code results. Once, maybe set a few variables, run a few functions. The REPL actually, thanks to JSON, has IntelliSense in it now. There's no code generation also with the type providers, which means, if you're doing something like Entity Framework, you're very used to generating these, massive amounts of classes that sit there. They need to be updated. They need to be maintained. Make sure that they're correct. Anytime the code source changes, you have to make sure everything is still in sync. With type providers, everything is always just in sync because there isn't that code generation. There is even a type provider that works with Entity Framework. The way that one handles it is it will generate the classes that it needs, bring those into the DLL, compile them in, and delete everything else and clean up after itself. So it's, there's not this extra code. There's not all of this extra stuff to maintain. Because of that, type providers can scale to millions of types. If you guys remember the Freebase database website, it was an interactive place to way to add a ridiculous amount of information. It was just a database that people could enter into, a Wikipedia-style thing. There was a type provider for that. And there's a type provider for all of the World Bank information, which is how I get in the demo I'll show you guys in a minute, it's how I get the list of the countries and all of their capital cities. There's also a tremendous amount of information that the World Bank captures on each one of these countries. And that's all available with IntelliSense. You get tooltips, everything that your tooling normally provides, you now get into your data source. And this works with not just, excuse me, this works with not just SQL Server, it works with CSV files, with JSON documents, XML. There's tons and tons of these, and you have all of these extra features right at your fingertips. So now let's look at, oops. Let's switch over here and look at this. So back to my type provider demo. So you guys had seen this run before, and you saw the Xamarin.Forms bit of this. We now should be ready to actually look. So let's start. I have a very simple one single type. This is actually a record type, which is very similar to a tuple. Tuples are groups of values that are specifically ordered but not named. In records, they are not specifically ordered and named. So it's just another way to group items. City, a country, and the name for the venue that I'll have. So actually, let's look at this venue list page. So here we're inheriting from a content page. I'm loading my XAML, which is here, just very, very simple stack layout with a list view inside of it. And back here, I'm grabbing those to use. I'm using an observable collection to be able to automatically update. And using a text cell as the data template. I'm setting the item source and the item template to the list view. And then declaring the table item. So in the Foursquare module that I'll show you guys in a second, I'm grabbing a list of valid countries. And then iterating over that list. Iterating does the same thing as mapping over a list. Mapping will return a new list, whereas iterating just produces side effects. So here I'm setting the text cell properties, the name of the country and the name of the capital city. And then to the collection, I am updating, I'm declaring this whole record type. So there's a country and a city. In this case, the name is none because I haven't looked up what the top venue is yet. And I'm setting the padding and the content. And then in the onAppearing, I have an update statement. So I'm matching the name of the country. So V is my record type that comes in, should pop up in a tooltip in a second. Well, that will pop up. In the meantime, I'm grabbing, the index of the collection here to sort for all of that, and then setting the value to be the new name of the venue that is coming in. So I'm just automatically updating that venue. Otherwise, I'm specifically removing that country because something went wrong in my check and Foursquare. Maybe the country isn't. Basically, there was an error, and I don't have that information. And then I'm running this all in an async loop. So I'm grabbing these valid countries, and for each country, I'm getting that specific venue for the country. And if that exists, using what's called an option type, which is a lot like a nullable in C#, but similar to a switch statement and pattern matching, it's a lot more powerful. So if you actually get a value back, then we update it. Otherwise, again, we just remove that because something went wrong and we don't have that information there. And then this is in an async, and I'm just running async start to get that going. So the Foursquare bits here, which have the actual type provider. So this World Bank get data context is the only line of code I need to have access to everything in the World Bank at all. So now at this point we can do, oh, this is tiny. So countries dot, so you can see, let's choose Ecuador. Ecuador seems like a nice country. Come on. And indicators is the thing that has, the internet's a little slow, but you can see there's a lot of indicators and a lot of information for each one of these. Manufacturing value added in constant 2005 US dollars. Number of listed companies per 1 million people. PPG, IBRD, parentheses, AMT, current US. I have no idea what that even means. But, but you can see there is a ton of information there, and it's all just at your fingertips, IntelliSense. You can type right into it very, very, very easily. So I'm getting that information from the World Bank. I'm declaring a path for the JSON type provider. I'm using 2 separate type providers. You can mix and match within a single file. So I'm getting a specific path to an example JSON. So for the JSON and the XML type providers, you point them to a specific bit of code, and then it can, produces a schema from that. So here we're creating this path, and then using that path to create this venues type that we can call into Foursquare. And then actually calling into Foursquare with this base URL plus near a specific city. And so this get venue for is my one longer function. So we get the city, the capital city, using the World Bank information. And if it doesn't exist, if the World Bank either doesn't have that information or it's being a little flaky and we can't access it at that moment, then just return none. Otherwise, then try to specifically load those venues near, that specific city. Again, if something goes wrong, just return none. And here, now we're doing a whole bunch of piping. if you folks have worked either with PowerShell or Unix shell scripting in the past, the piping is the same concept. You take the previous, the starting information venues, and you're piping that in as a second parameter to the next set of information. Does the exact same thing. As long as the output of the previous function matches the input of that next function, you can just continue piping, which you can see I have done. And this is one of the things I was talking about, going all the way back to the beginning, that Jet found so easy. Being able to just insert an extra function call to log something as just an extra pipe is trivial and kind of beautiful when you look at it. Maybe it's just me. So here, we're taking these venues where there was a lot of, the JSON was set up a little weird. So there was a lot of processing that I needed to do to actually get into that. So there's groups, and there's a recommended section of groups, and you have to get the items. You have to try to get the first one from there. And once, the items was within a second thing of items, and so we get the top one of those as well. But eventually we come down here, and assuming that all of this actually exists, then we return our specific record type that we had before. We have the country with the country name, the city with the name of the city that we're looking at, and the item with the venue name. But again, the only bit of the type provider that we have is, we're declaring a path here, we're creating an example for the type provider to use here, and we are actually loading this information right here. So there's three lines for this one. But 3 lines for that type provider for the JSON one, and 1 line for the World Bank information. And the rest of this is just processing the data that actually comes out. Here's my valid countries. If I specifically know that the capital city doesn't exist, then I filter those out in advance, and I don't have to actually do that extra filtering. So that is it. Any questions on this demo? Is that a question, or is that a, no, okay. So again, that's easy use of async and type providers combined. Let's see if I can get back. Yay. All right, so some existing type providers. This is not all of them, and there are some ridiculous ones. There's a DonSime type provider. It basically lists out Chuck Norris-style feats that DonSime clearly has attained. It's ridiculous and awesome. I don't know where it is. There's a squirrels type provider. Again, there's a rock, paper, scissors, and a Minesweeper one. There are also some really useful ones. There's an R type provider, which works on in both iOS and on Windows. And basically, if you do a lot of data analysis, any bit of code that you run in R, you can call into your R code. And as long as you have R actually installed on your machine, it will pop up R charts for you from F# code. That one's very impressive and a lot of fun to work with. There's a CSV type provider, the JSON one I showed off, the XML one. There's SQLite type provider, which I had used last year to rewrite the Tasky app. And there's a very simple, very lightweight, a fun one to use. The WSDL one actually is the type provider that got me interested to begin with. I was working on a terrible project that had endless updates, and my life would have been infinitely better if I'd been able to use the WSDL type provider. So there are a couple, as you can see. You can also, as I mentioned, you can mix and match them. So you can get data from an RSS feed or from SQL Server or from the World Bank all together, and then process it maybe in R, and mix and match these up, and maybe get data from 2 different places. Process it. There's a PowerShell type provider as well. Process it with one of these, and then visualize it maybe with R type provider or back in F#. There's a bunch of great charting libraries in F#. And it's very easy to mix and match all of these things. Oh, good timing. OK. So my final reason why you should consider F# for your mobile apps, you don't need a Ph.D. The monads are just monoids in the category of endofunctors. Yes, that's an actual statement. But functional programming in F#, specifically somewhat less so than generally functional programming, certainly has a reputation for being the complicated thing and much too difficult for your average person to figure out and to learn. This is my friend Sean. Sean is 8 years old. And, well, actually, Sean is 9 years old now. When he was 8, he started speaking at large conferences, even larger than this one. NDC Oslo, I believe, was his first one. But it's 2,000, 2,300 people. And it wasn't just a cute little, like, I'm 8 years old, here's my Hello World app in F#, please clap for me now. He was doing very interesting, very serious things using 3D image modeling. And, it's not, he's 8, you guys. Sean's father, now in fairness, is also somebody who knows a fair amount in the F# world and has encouraged his son to go out and speak. But one of the reasons he did so was because F# has this reputation as being the complicated thing, and they wanted people to look at this and be like, well, if Sean can do this, he's 8, maybe I could start to consider this as well. So you guys, an 8-year-old can program in F#. There's no reason for any of you not to. And thank you tons. Oh.